Well, good morning to you, and ready for another exciting lesson. So here we go. I can't be there in person, but we'll go ahead and discuss what you need to do. Today, actually, we're going to focus on measuring relationships called correlations with a number, okay, to determine the strength. First of all, if you want to look at the homework answers are posted under topics online, so I won't go over them. If you have questions, I'll answer them next class. So we'll just run right through the homework and into the lesson. First thing, about correlation. We use the variable R for correlation to measure strength. Some things you should know about correlation. Correlation is a value between -1 and 1. -1 being a strongest negative correlation, 1 being the strongest positive correlation, 0 really being no linear relationship. So 0 is, the closer you are to 0, the weaker you are. The closer you are to -1 and 1, the stronger your correlation is, and the closer your dots are to a line. Positive correlations, of course, are greater than 0, negative less than 0. Okay, 1 and -1 are perfect linear associations. The dots, the data falls exactly in a straight line. Okay. The value of R has no unit of measure. We don't say R inches or R no unit of measure. It's just how strong the relationship is. If we change X and Y, remember we talked about explanatory and response, if we change them, the correlation does not change. Later we'll find out something that does. Okay? And it only measures how close it is to a linear association. It doesn't tell you, there could be other associations, curved or other patterns. This only deals with linear, how close data is to a line. Okay? So, although you're not going to be asked to guess correlations, we'll give you an idea of what strong numbers looks like and what weak ones look like. So looking at the first one, rushing attempts to rushing yards in 2008, let's see what this correlation is. That's a 0.89 if you can read that. That's pretty strong. It looks pretty close to a line. That's what a 0.89 correlation would look like. Of course, the next one you would guess is pretty strong also, but it's a negative side. So we're going to look at a negative number. That's negative 0.97. That's so close to a line. It's about as strong as you'll see. The one down here now kind of looks pretty weak. I would say it looks a little negative to me, and it's probably pretty weak. It's a negative 0.31. So something like that, closer to 0, weaker it is. The other one looks kind of strong, positive, and that's a 0.82. So give you an idea what these look like. We have a couple more. This one looks a little positive. Let's see, 0.54, not too bad. And this one, well, negative 0.04. That's almost the point where we don't see an association at all. So that's what correlation does. It's supposed to measure how close data is to a line. And so we move on. How do we find that number? Well, first of all, there's something on your calculator we're going to have to change so that it's a one-time thing to make sure correlation shows up on your calculator. And here's how you do it. Grab your calculator. If at any time you need time to do something, hit pause on the video and you can take care of what you need to. But take your calculator and hit the second key and the number 0 at the bottom. That takes you to the catalog of all things. Use the arrow and just scroll down to the one called Diagnostic On. They're in alphabetical order, so look for Diagnostic On and press Enter twice. And then you'll see this done here, meaning you've taken care of that, and no longer on this calculator will you have to do that. It'll show you a correlation. So make sure that's set up for the next thing we're going to do. So here's our golfers again. Let's find out their correlation. So pause this while you enter that. Enter their driving distance in list 1 and accuracy in list 2. And then return here, and I'll tell you how we get along with the rest of it. So pause this for a minute while you do that. Okay, we're back. So now what you do to get correlation, we go to Stat, and we move over to Calc, okay? And we go down to number 8, Lin Reg A plus BX. Don't use the AX plus B. Use number 8, Lin Reg A plus BX. Hit Enter. If you have the wizard or the thing that asks you where the lists are, you're going to do L1 and L2. If you don't, just do L1 comma L2, okay? And the rest of it should just stay the same. When you hit enter, you can get 5 lines, and R here is the correlation. The correlation between driving distance and accuracy here is negative 0.905. That's pretty strong. Seems like accuracy as driving distance increases, there's definitely a loss in accuracy. So try that out and make sure you get those numbers. If you didn't do it on the calculator, here's the small formula you would have to know how to use right here in order to calculate it out, which we won't have to in class. But if someday you take statistics and they want it by hand, that's what you're looking at. Remember one thing, just because there's correlation or association doesn't mean that one thing causes the other. Okay? Doesn't mean longer driving distance causes the ball to go out, be less accurate. So it doesn't mean it isn't, but we can't do it just because one correlation between two things doesn't mean one causes the other. Okay? Now let's you try. Here's the 2009-2010 Lakers back when they were good. So I want you to actually put this data in list 1 and list 2 and see if you can come up with the correlation to see if there's a relationship between the number of personal fouls a player gets and the number of points they score. Okay? We'll pause this for a minute while you do that before I show you the answer. So please pause. Now to move on to the answer, you should try this to make sure you know how to do it. But here's the correlation you should get. 0.767, which is somewhat moderate, okay? So, but we can't say fouling more causes you to score more points. That's not the case. There's probably other reasons why you score more points, okay? More fouls you get means probably the more playing time you have in the game, an opportunity to score more points. So understand, just because there's a relationship doesn't mean one causes the other. Anyway, hope that makes sense and you understand now how to find correlation, because now we start our homework. I'm going to scroll through these problems so that you have a chance to pause it and do the problems if you don't have access then, but you can work on these in class. So here's number 2, 13 and 15. I'm moving slowly so you can pause. Here's the other 3, 17, 19, and 21. Hope you have a nice weekend, and we'll see you next week.